today we're going to be learning another integration technique. If you remember, last week we learned integration by substitution, and we've been using that all along. Technically, the method that we are learning today, integration by parts, is not required on the AP exam. Everything on the AP exam should be able to be done by substitution, but integration by parts could be easier on some of them, which is why I want to show this to you and not leave you doing it the difficult way, if we can help it. So, integration by parts is usually used when you are trying to integrate a function that looks like a product of two functions. So like x squared times ln of x times sine of x with integral of ln of x dx. And there are some guidelines. We need to pick a u, we need to pick a dv, and some generic guidelines for that are try letting dv be the most complicated part and the u be the remaining part. Another thought is try letting u be the portion whose derivative is simpler than u is, like an x squared becomes a 2x, or a 3x squared plus 1 becomes a 6x. Those are simpler, so that would be the kind of guidance you want to make the u. Then dv will be the remaining factors. There is an acronym that will help you also get an idea of what you should make the u and what you should make the dv. So you're going to want to write this on your notes because it's not there. Use this acronym as a guide. The closer it is to the top, the more likely it is to be u, while the closer it is to the bottom, the more likely it is to be dv. And I late is that acronym. I stands for inverse trigonometric function, L logarithmic functions, A algebraic functions, T trigonometric functions, or E exponential. So the closer it is to the top, the more likely it is to be your u. The closer it is to the bottom, the more likely it is to be the dv. So if we look at this first example, we have an x and we have a sine x. Back at this isolate, is algebraic or trigonometric closer to the top? Well, algebraic is closer to the top, so we're going to make our u x and our dv sine of x dx. Now, what we need to do is derive u and anti-derive dv. Typically, when we derive u, we get the derivative of u in terms of x, so we would get 1, but technically, du would equal 1 times dx, or just dx. So keep that in mind. Either think of it as du dx and always multiply that dx over, or always just put the dx when you derive. Antiderivative of sine is negative cosine of x. Now, our formula for integration by parts, we go u times v minus the integral of v du. So, u times v is going to be negative x cosine of x, that's u and v multiplied, u times v, minus the integral of v, which is negative cosine of x, du. And du, we decided, was dx. So, we plug this in. Bring this negative out front, so it becomes plus the integral of cosine of x dx. Is cosine of x something that you know how to antiderive? Yes. So we can make this negative cosine of x, negative x cosine of x. Antiderivative of cosine of x is sine. And it's an indefinite integral, so we have to make sure that we put plus c. So it's not tricky. You are going to want to remember what to make your u and what to make your dv, and also remember the formula u times v minus the integral of v du. Let's try another. ln of x. Back at isolate, the top inverse trigonometric functions, then logarithmic. So we should make our ln of x our u, which means dx is going to be our dv, which feels funny, but we don't know how to antiderive an ln of x, so we have to use parts to do it. So, if I do this, the derivative of ln of x is 1 over x, and don't forget to add your dx, because technically it was under here, and we moved it up. The antiderivative of dx is just x. because think about this as being a 1. So now u times v minus the integral of v du. So x ln of x would be u times v minus the integral of v du. Working out pretty simply, x times 1 over x is 1. So we end up with x ln of x minus x plus v. Now, occasionally, as we turn over to the back of this sheet, occasionally we have to antiderive twice. And if you notice here, we've got an x squared, we've got an e to the x. Which of those is going to be closest to the top and highlight? Well, exponential is the very bottom, and algebraic is above it, so we're going to make our u our x squared. Again, also think of the item for u, that derivative is simpler. The derivative of x squared gets simpler. The derivative of e to the x is the exact same. So oftentimes, e to the x will be your dv. So we get 2x dx, and the antiderivative of e to the x dx is e to the x. Now, u times v, x squared e to the x, times the integral of v du, so 2x e to the x dx. Now, we need to simplify this a little bit. I'm going to pull that 2 out to the front so it's out of our way. And this is still not something that we know how to antiderive. We're going to do parts again. So, let me switch colors here. So you can see that we've moved on to the parts the second time. Your u is going to be your x, because its derivative is simpler. Your dv is e to the x dx, because e to the x is almost always your dv. Which means du is 1 dx, and v is e to the x. So, now we still have our x squared e to the x minus 2, but now for this integral, we're going to do our uv minus the integral of v du again. So uv x e to the x minus the integral of v du, which is e to the x dx. Nice thing about this is our integral we are left with here, the e to the x dx, we know how to antiderive, so we're going to do that. We've got x squared e to the x minus 2, and this, in parentheses, we still have our x e to the x, minus the antiderivative of e to the x is just e to the x, plus c. So if I simplify this a little bit, x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Minus sign, or this part of my equal sign just flew away from me. So look these over closely, come with questions tomorrow. I want you to try example 4. You'll probably get partway through it and notice something, and we're going to talk about number 4 in class tomorrow. So come with questions, but please give number 4 an attempt.